All right. Hello, everyone. Welcome to Google's sponsor session at SIGMOD 2021. And my name is Kong Yu. I'm here recording this video on Monday, June 21st, as a quick intro into database management research at Google. And after the recorded video, my colleagues Jeff and Famar will join me, and both of them needs no introduction, and we'll be all here at the live session for Q&A. We only have 15 minutes, so I will keep the presentation very short to leave plenty of room for Q&A. And after the session, the video will be uploaded to the sponsor booth on Hoover, so you can tell your friends to watch before the conference ends. Right, so let me move on to the next slide. So first of all, let me just emphasize that database management research actually happens across the entire Google. Whether you're interested in scale, speed, or insights and knowledge, or even trust and safety and privacy, and there is a place at Google where you can enjoy doing cutting-edge research with some of the smartest colleagues across the world. And so just as a brief highlight of some of the research that's happening across Google, let's start by looking at the, for example, core data infrastructure for ads, machine learning, and many others. Just on ads alone, from the public data from Google's earnings report in 2020, there's more than $100 billion worth of data flowing through every year. So you can imagine how important these data infrastructure are to Google. Some of the most well-known work you're probably aware of, including some of the data analytics like F1, NAPA, MESA, and Diametrics, which Jeff can tell you more about, actually won the VLDB 2020 Best Industrial Paper Award. It is an end-to-end system that measures query engines on their performance. And for example, on ML, for example, there's also crowd data management and how do you efficiently generate and manage the data for machine learning. And moving on to cloud, and again, there's a lot of very cool and exciting infrastructure work that's happening in the cloud product area, including the well-known ones like Spanner and Bigtable, and as well as BigQuery. And Famar will be able to tell you more about recent progress in BigQuery if you are interested in the Q&A session. And what's very interesting in BigQuery is there's this new, not really new, but very important initiative in terms of integrating machine learning into BigQuery so that some of the very sophisticated advanced machine learning training and prediction can actually happen within a SQL-style query language. And of course, there's data fusion for integration and data prep for clean and prep the data for the machine learning algorithms. And Search Assistant and Geo, of course, everybody knows the knowledge graph, which has very significantly changed how search engine is presenting information to our users, and as well as question and answering all these kind of cool stuff that's going on in the consumer-facing space. And I'm actually from the research org, and I'll do a quick 5-minute shallow dive into it in the next few slides. And just remember, this is just a very tip of the iceberg of all the data management related research happening at Google. There are many, many other areas. So as I mentioned, I'm from the research org. My personal research interests are news and social media understanding, as well as information integrity. But I'm here not to talk about those, but mainly I'm here to tell you about some very exciting recent development in giant language models that's happening across NLP and the machine learning field, and what that means actually for data management and system research at large. And I don't know how many of you are aware of this. If you are somewhat familiar with NLP and ML research, you would know like there's this so-called transformer architecture for language modeling that was published by Google and open sourced in 2017. And that has ushered in an era where increasingly big giant language models are doing better and better and achieving comparable performance comparable to human as on some tasks. That started with BERT, and which is an encoder-only architecture, and then to T5 and MUM, which everybody probably know from the Google I/O earlier this year, and then to GPT-3 from OpenAI, and Lambda, which again, both of them are decoder-only architecture. What's common to all these giant models is like they're using humongous web scale data for training examples for the training, but as well as the model itself are super large. So challenges here, billions of training examples and models with more than 100 billion parameters that are happening. So these are scale challenges that that is unprecedented. And as data professionals, we kind of aware so-called data parallelism, and how do you distribute the data across the different machines, and being able to parallelize it and speed things up. But with those giant models, another interesting but super challenging problem is the model itself won't even fit let alone a single CPU, but TPU, but more than like thousands of TPUs. For example, in the latest paper, the core infrastructure team has published a pod which actually contains more than 4,000 TPUs in order to be able to train such models. So, and you have to be able to parallelize the model itself in order to be able to train those giant language models. And those coupled with the web scale of training examples, the need to manage all these data and the need to understand how data flows through, presents very interesting system and data management research challenges, and that is spurring lots of innovations in system for ML. And along with those challenges, of course, there's lots of opportunities. The performance of those giant language models is so good now that we can really start to think of solving really, really hard problems that previously were not possible. For example, in my own research group, we work on news understanding. And one of the problems is to be able to summarize a news story and with many, many different articles. And just to give people a very high-level overview of what the story is about. This is something called a headline label. And previously, it was not very easy. And with those giant language models, we started with BERT and moving on to other bigger models. You can actually achieve labels, headline labels that are comparable to what a human would have created. And there are many examples, hard problems that were previously impossible to solve using machine learning, and that is now enabled by these giant language models. And of course, as we all see from the Google I/O, it can also enable very novel applications, natural conversation. So here's a piece of the conversation from Lambda. And it's a very interesting conversation that that is making the machine almost human-like. So that opens a lot of possibilities of what a machine can do in the future. So again, there are many, many more, even just in the Google Research org. For example, another area of my research is information integrity. How do you do claim extraction and understand the veracity of certain statements? And my colleague, Natasha Noy, has been working on so-called dataset understanding and search. There's a dataset search product, a consumer-facing product that you can play with. And Sandeep, another colleague of mine in Google Research, has been doing information extraction from private corpora, which presents very interesting challenges compared to a web corpora that is fully open. Then, of course, we talked about system for machine learning. And machine learning for system is another angle where can we, for example, learn indexing structures using machine learning techniques. that will improve and optimize the performance for systems, including database systems. And then machine learning workflow management, which is very complicated, especially with those giant language models where you do pre-training as well as fine-tuning and sometimes multitask fine-tuning. So there's a lot of workflow management work. And then, of course, the long-standing topics of graph data, stream data, and privacy and fairness. And there are truly a lot more. And this is just in the research org. There are plenty more across the different other orgs, including core, ads, and cloud. And if you're interested, and here's the email, google-at-sigmod@google.com, where you can reach us with your questions, and feel free to send us resume directly as well. And given that, and I will stop recording.